Evaluating radicals is one of our key things. And when I say evaluating radicals, I'm going to be a little bit more broad. What I really mean is simplifying radicals a little bit. Let's take a look at what I'm talking about. So I want you to notice when I'm talking about radicals, some people say, oh, you mean square roots. Now, a square root is a basic type of radical, but the other types of radicals have other indices. An index tells us whether it's a square root, a cube root, or so forth. So we got some vocab out of the way. Its index tells us what type of root we have, what type of radical. We have the radical symbol, and the stuff under the radical is called the radicand. That's what we're going to go ahead and try to crunch down and manipulate. The number outside the radical is called the coefficient. And if the index is not shown, the index is sometimes missing. That's just to assume it's a 2, okay? Just assume it's a square root if we don't have a number there. Otherwise, we're going to look for numbers to tell us that it's something different, okay? A few things, though, is that we can actually do square roots. What we can do is we can separate them or combine them depending on what's easier in our situation. The one thing we need to watch out for, or one of the biggest things, is that the square roots of negative numbers are undefined. They're not real, okay? They're actually imaginary or undefined. So let's go ahead and take a look at these 6 examples. First up, square root of 36. This is a radical, but it's a square root because there's no number there, so I'm going to assume it's a 2. And what that means is if I were to factor this into 6 times 6, I have 2 of those. And so what a square root does is it says I have 2 of those, and so I'm going to crunch those down into just being 1, okay? And so a square root is the opposite of squaring something. So anytime we have a square root and something squared, like 7 squared, we would say the answer is 7, okay? So the square root of 36, 6. Now these are pretty nice because we can literally type them in our calculator. We can also work backwards. 36 is 6 squared. This one at first glance looks pretty easy, but then we notice that there's a negative in front, which looks a little scary. This is a square root, and we know that 5 squared is 25, okay? So I would normally go, oh, good news. I know that the square root of 25 is 5. But the fact that there's a negative there gives me pause. It makes me say, oh, wait, I know there was something with negatives. If there's a negative on the outside of the square root, it's okay. That means we're going to keep a negative right where it is. Okay, what we need to watch out for is if the negative's underneath the square root. Here's an example of the negative underneath the square root. So if you're not paying attention, you might go, oh, I'm going to square root 81, and I would get 9, and then I would get a negative. But that's not true. That would be negative square root of 81, would be negative 9. When we have a square root with a negative underneath it, we say undefined. You'll also hear does not exist. And you'll also hear imaginary or complex. There's lots of words that we've used over the last, few hundred years to deal with this situation. But the bottom line is there's not a real number that when we square it gives us negative 81, because if it was negative, it would cancel out the negative. And so if we have a negative under the square root, I don't need to do any math. The answer is undefined. Now, this time we have a fraction. And when we have a fraction, there's a few things we can do. We can try to simplify the fraction. Unfortunately, 4/9 doesn't simplify. The other thing we can do is we can treat it just like if it was 2 square roots, just like this. Square root of 4 over square root of 3. I'm getting ahead of myself. So we can split it into 2 square roots. If we ever have a fraction inside of a square roots, we can split the square roots into the top and bottom. And that allows us to simplify this a little bit more and give us 2/3, because the square root of 4 is 2 and the square root of 9 is 3. Now, up until this point, we've done a lot of square roots, but what is this? This is a different index. This is a 4th root. So instead of looking for a set of 2 things in there, I need a set of 4 things multiplied together. So what we're going to do is we're going to try to factor the square root of 16 all the way down and see what we have. So first off, if I were going to factor 16, I'd say it's 2 times 8. I'm using a factor tree here. If you have another way to factor, that's fine. 2 times 8, and then I can also do 2 times 4. And then 4 can break down even more. So I have 2 and 2. So the fourth root of 16 is like saying the fourth root of 2 times 2 times 2 times 2. I'm going to double check in my calculator. 2 times 2 times 2 times 2. Yep, that equals 16. So notice that our index is 4, which means I'm going to take all 4 of those and crunch them down to just a single 2. So the fourth root of 16 is 2. I want to kick it up a notch for this last one. This is the last one I want to do here. One, I want you to notice that the index is a 7. That's kind of a bizarre one. And then I also want you to notice that I have variables in here. I don't want you to freak out when you see variables like x's and y's and a's and b's and c's, because what I want you to do is I want you to recognize the pattern that's happening, okay? When we have this, that's like saying we can split it into pieces. That's like saying the 7th root of x to the 21 times the 7th root of y to the 42. So you don't need to think about this like a big problem. This is really little problems, okay? Now, if that doesn't obviously make it more simple, let me show you the next thing I want to do. When we have an index and an exponent, what we can do is we can try to make as many sets that match the index as possible. So x to the 7 times x to the 7 times x to the 7. So when I split it up into 7s, that would be 3 7s to make 21, because 3 times 7 equals 21. So that means this whole thing just crunches down into x to the 3. Okay? The other trick way to do this is just say 21 divided by 7. Okay? So I can jump over to y to the 42nd. If I were going to simplify this, 42 divided by 7 is 6. So I'm going to say y to the 6th. Now remember that we had both of these combined, so this combined is my answer. And they're just going to multiply together, x to the 3rd, y to the 6th. I want to give you a few that you can try on your own. So these follow the same pattern. Give them a shot. If you want to know if you got it right, you can toss in the comments, and I'll let you know if you got your answers right. Try them and let me know in the comments. Thank you so much. Like and subscribe. See you next time.